Okay, let's bring a conclusion to this particular problem with this third and what should be a final part of the series. So last time when we left off, we were talking about, or at least I was presenting information on the increasing and decreasing nature of the reciprocals of quadratic functions. So let's complete this particular thought. When the y values for the quadratic are decreasing, the y values for the reciprocal are increasing. Okay, so with that information at hand, we can go back to our graph and continue our sketch. So I'm going to move from left to right as if I were reading a graph. And if I consider this point of intersection to the left, the y values, as you can consider them here, are increasing. And that's as x increases. That is moving further to the left towards negative infinity. So as those values grow larger, we would expect that the y values are going to tend towards 0. So the y values start, they are very small, and as we approach the point of intersection, the vertical asymptote, we're going to see those values increasing. And then they're going to increase indefinitely along the vertical asymptote, always getting closer and closer to it, but never touching it. Okay? Now if we go to the other side, and if we use symmetry about the axis of symmetry at 1.75, what we're going to note is that for these very large values of y, as the graph grows indefinitely, that is, the domain increases towards positive infinity, we're going to see our y values continuing to decrease indefinitely as x gets larger. Along the asymptote, those values are going to be decreasing. So I'm going to draw it more simply by moving upwards. So in that general direction, never touching the VA, we'll see the y values decreasing as x gets larger. The final portion of the graph requires a little more study. If we look at the region between the turning point or the vertex of the parabola and moving our way over towards the region that right in this area here that is approximating or getting closer to the VA, okay, we're going to start by sketching a representation for that. Notice that the part that was just circled, those y values there happen to be decreasing for the parabola, right? So as you follow the parabola from top to bottom, moving in this direction, the y values are decreasing. So I'm just going to move this out of the way. That means that if they're decreasing, we should see an inverse variation. We should see the y values increasing. That is, increasing along the VA, never touching it, intersecting that blue point, point of intersection, and carrying forward or onwards towards what would be a high point. And let's assume that that high point is here right now. We'll calculate it in just a moment for our sketch. On the other side, and also by using symmetry, we know that the y values in this region here, as we tend towards the vertical asymptote, are certainly larger than those that would occur down through this region. Okay? Which means that these values here being large would then end up being graphed as being small. In terms of this direction here, so let's extend the graph this way. Okay, these values here are actually decreasing. Okay, so they're growing smaller. That is, they're large negative numbers. And we'll complete our graph by finishing it off by connecting it to that high point that happens to be there. Okay, so just to recap, the function is decreasing in this direction. So therefore, the y values must increase up to the high point. Over on this side of the graph, so in this region here, the y values are increasing. So therefore, from the high point, they must decrease. So it's an interval of decrease. So with that, our sketch of the reciprocal is complete. So if we were to label the equation of that, we would have, and I'll use green to color code, right? We have the graph of y equals 1 over 2x squared minus 7x minus 4. Last but not least, we should make a note of the high point. Now if we go back and look at the work we have done for the vertex, okay, so I'm going to cut this statement out and we're going to use it again. Okay, so according to this statement, the vertex has these coordinates. This means that the graph of the reciprocal to this quadratic function has a high point at the same x-coordinate, and you can see that on the graph, but because it's a reciprocal function, it's going to have a high point or a y value for that point at the reciprocal of that y value. And if we were to determine a decimal equivalent for that particular point, what we're going to notice is that it's about minus 0.1. So that is equivalent to, or approximately equal to, 1.75 comma minus 0.1. And again, that's negative 10.125. So minus 0.1. If we go back to our graph, this particular high point minus 0.1 is only 1/10 of the way along. So if I can grab a hold of this blue point, or the rather elusive blue point, just move these pieces of the graph aside, and we'll shift that up just so it's just underneath the x-axis. And there we have the coordinates for that particular high point. The only other point that can be determined is that of the y-intercept. So the y-intercept just grab a purple pen, is right here. Okay, so the y-intercept for the parabola, if we were to study that and make a note of that. We'll just check our video time and we're about to close it off. So it occurs at 0, comma. If you calculate it or if you take it off the graph, it should be at 0, comma. Let's double check here. Let's check that graph and make sure that we've got this appropriately. It looks like -4, so we could also calculate that. But it looks to be at 0 minus 4. So therefore, the y-intercept for the reciprocal occurs at 0. And the reciprocal to that is -1/4. So by running through this video, again at your own pace, by looking at each step of the process, you'll be able to graph functions of this particular style. Okay, so in terms of the practice that you can do to consolidate your learning would be found on page 347 of your textbook. And I would ask that you complete number 12 along with number 13, but I would like you to do parts A, C, and F. And that involves sketching the graphs of those particular functions.